This is now on behalf of the community, the people who are present on this call. We need to broaden the community involvement in the decadal process. Those presentations that we heard today will have to be brought into the format of white papers and basically show what community can do and what it wants to do. So I'm open the floor for discussion on this topic, but let me just maybe suggest broadly that the presenters of several talks that we heard today would probably a good focal point to organize community response along the relevant areas. For example, gravitational waves that were covered by talk by Jan and Chris. So this may be one or two papers. There will be several papers in terms of contribution of the squids to detect lunar seismology and also gravitational waves, and the Jan's paper on lunar gravitational wave antenna. And of course, Simone Delaniello, the effort that your group and your collaborators already mounted into putting corner cube reflectors on the moon upcoming CLIPS missions, that should be broadened and maybe also bring in some active technologies such optical transceivers. That may be an excellent area to develop. And then Jack Wilson's the neutron sensors on the moon. That's an interesting topic. Marshall, with your presentation, I think lunar or cislunar navigation is a critical infrastructure development, and our community can contribute broadly, not only to the science, but really application and building infrastructure that will enable PNT services for broader community to have.
Slava,
So I
can I
guess
ask a
it's one of
about that?
absolutely.
So we put in 3 or 4 white papers on lunar geodesy type stuff, lunar laser ranging and so on. Vishnu had a lot to do with those. What is the difference now? What is the difference between the white papers in the planetary science and the white papers here? Is it just fundamental physics or what?
It is lunar surface, and we are on the lunar surface. We need to make sure that our approach is benefiting from the presence on the lunar surface, and maybe use of orbiters for relay constellations. So in your case, I guess having landers with precision instruments such as clocks and maybe transponders or VLBI measurements enables the type of observations you can do. So we need to may be relevant to the objectives within a biological and physical sciences division, because this is what the division is interested in. So whatever have you written before may address other objectives, but here we are talking about the moon and lunar surface. Does it make sense?
Should then we have one on test of general relativity?
Absolutely. Absolutely. This is the science that drives the development of that infrastructure.
Because as I'm sure you know, there'll be some new ones that can come out with, these combinations of data sets and so on.
Marshall, it sounds like you may actually contribute to several papers because it's the topics of the science and the infrastructure and the technologies that you have monitored and you contributed to. Very good. So does it answer? So I guess that's pretty much my take on it. Ulf, would you like to contribute a little bit more as to focusing on the topics? Because we in the past we contributed to several white papers to astrophysics, planetary sciences, but now we have to be coupled to the moon, right?
Yeah, that is true. But I mean, the decadal survey is in general physical science and biological science in space. So the moon is just the topic of today's conversation. But I think to answer Marshall's question, the distinction here is that we're part of the physical science division of headquarters now. So you have to do with your technology and your science, you have to address physical science or fundamental physics. That's the key thing. It should not address things like are covered already by the planetary science, for example. It should be distinctly for physics, for example.
Absolutely. And also, if that paper was submitted to the other decadals, but it and will not be submitted to the planetary to the BPS, it will not be considered. So we just have to submit the document directly to the website where BPS will be accepting those white papers. So we should not expect that if we did something in the for other decadals and mentioned Moon as a potential, a body where we can benefit from the deployment of several technologies, we should not assume that that will be read by the decadal committee and will be considered. So we have to work with the decadal committee that is going to be addressing this type of sciences for the BPS. Does it make sense, Marshall? All right. So
that was just the sort of thing, the sort of detail I wanted to know.
Absolutely, absolutely. I think this is very helpful. So we need to be able to entertain the thoughts of and objectives of the BPS community, biological physical sciences, and really focus on the science. These are the science white papers, and then there will be also white papers developing discussing the infrastructure that it will be that we need and how we can contribute to that infrastructure. So both science and technology and community organization activities are also important. So we need to show the current state of the community and where the resources should be allocated to support the community in the upcoming decade. And so supporting maybe students and PhD students and the sort of community in broad terms. We also need to contribute with these discussions to the white papers. And so there are some activities that were funded by other divisions, such as STMD funded development of LCRT, a Lunar Crater Radio Telescope, which is funded by NIAC. I think it's an excellent transition strategy or approach where these efforts that were developed within one part of NASA can actually be transferred into the mainstream development of lunar infrastructure. So I do expect that the documents covering the science, exciting science, which can be done from the craters on the far side, in terms of long wavelength, will be also brought into the discussion, and so that's exciting. And Gerard, I think your presentation showed us we need to consider optical telescopes on the moon, and I think it's extremely important for us to step up and bring in those technologies in the decadal. So with this long summary, what I'm trying to say is that I do expect that the presenters of the talks today would would pioneer the development of appropriate white papers. So can we count on you on that? So because this is the way to actually organize the community. Any comments on what's been discussed? And I hear some responses from several attendees that yes, indeed, that would be the best way. There's some agreement from some presenters today that yet indeed this will be the topic. But what is your take? The presentations today touched base on multiple areas. Are we missing something? What else should be considered? And maybe a sort of a phased approach. The phase one, when we have mostly robotic presence on the moon. A phase two, when we'll have human and sort of mixed presence. Should we bring in different horizons for technology development, or how do we approach that? Because some of the topics will require some infrastructure already available, like relay communication orbiters, or some other robotic activities on the far side, for example. My take on it, I guess we should bring everything in. And just to summarize the wealth of the ideas that this community has, so that it will be heard. The reason I'm bringing this up because in the BPS, the first word is the first letter is B, and the P is only the second letter. So we need to make sure that we are equally represented. Physical sciences should be heard, and that depends on the community response. It depends on us. Anybody want to comment on this?
I just had a quick question. So I'm definitely very excited about the idea of writing a white paper for this. One question is, you mentioned about trying to avoid overlap with the other decadal surveys. So specifically for the LCRT project, I was wondering if the fact that there is some overlap with the astrophysics decadal survey. So we did not submit a white paper to the astrophysics decadal survey on this concept. We only recently started working on it. But would it still be beneficial to submit it to the BPS decadal survey?
My answer is yes, absolutely. So we need to bring in the topics that are the white papers that will be relevant to maybe multiple NASA divisions, and that shows the strength of the moon and the approach that we take. So by all means, Ashish, please bring in that white paper.
Thank you.
Any other comments on potential areas?
Slava.
Hojan, yes, please.
Yeah, so we were long ago from Wolf. We were fundamental physics was part of this ISS science.
Mm-hmm.
I think was it Mark Lee who
Absolutely. Mark was right.
So we are still stuck together with biology. Biology mainly probably is about this human inhabitation in space on the moon and Mars. And we are talking about fundamental physics. Why are we married to biology?
Let's take it as basically, Hojan, my apologies, but I think this is reality. We just have to deal with that. And so we should not question the origin of that, but at this moment, this is what we dealt with. And also there are some common topics like dust mitigation, because dust mitigation techniques are common for the human presence and the physics packages. And also the thermal issues will be similar. So there are some similarities, although we have different objectives, definitely. So that's kind of my take. And Ulf, I guess if you want to comment on that as well, that would be very nice. But otherwise, I guess physical sciences. Let's focus on physical sciences, and we need to make sure that within 4 areas of the workshop we had today, physical sciences is only one, and so we need to make sure that we will be at the decadal. Any other comments?
There were a series of workshops that I think NIST put on. They were called Fundamental Physics Decadal Survey Workshops.
Mm-hmm.
I attended the one on high performance clocks in space, and they had a sign-up sheet. And so it seems like that. I mean, while you were talking, I was trying to find the various links, and I can't yet, but I have them somewhere. But
Mm-hmm.
there should be we should touch base with those people.
Absolutely. I think as we develop those white papers, I think we need to broaden the community and reach out to those synergistic organizations or communities that actually will benefit from that collaboration. I think we need to make sure that we represent as many scientists as possible, because ultimately, the larger the community we represent, the more sort of space at the table or on a place at the table we will have. So realistically, we need to make sure that we represent a healthy, energetic community that actually is eager to benefit from the upcoming opportunities. That's the key.
Slava, this is sort of to take Marshall up on that. I mean, it might be good to right now to actually sit down and write down, have somebody write down a sign-up sheet of people that are committing to do what kind of white papers, and actually we do it now.
Excellent. I think I like that idea very much. So I can initiate that sign-up sheet, and basically we'll see if there is anything that we can come up with at the moment. So maybe let me just bring in the Excel spreadsheet. I will start sharing, I guess, with everyone here. And apologies if you will see my mistypes at the real time, but basically this is what the typos. So I guess I'm just increasing the size here, and maybe let me do this. So as we go through the presentations, let me just start with gravitational wave observatories. And I guess, Jan, would you be willing to begin sort of to lead the white paper on on the gravitational wave?
Yeah, sure. Sign me up for it.
Excellent. So Jan, I will put the last name later. So then, who else? I guess from the community that is present here on the call, who would also will be interested to contribute to that paper? Is there anybody immediately can jump on and contribute to that?
You can count on me. I have an interest in lunar gravitational wave detector for.
Our guest, Hojang, yes, definitely. So it's. You're here, and basically, I guess we'll reach out to other people in the community as well. But Jan and Hojan, would you be so kind as to start organizing that community, people whom you know, and try to bring as many people in the white paper, justifying the use for the moon as a gravitational wave. And Hojan, you've done a lot of work through your career relevant to these activities. So then
actually there's two really there, because one is using the moon as a, the normal modes of the moon, and as a resonator,
right? And so spherical gravitational wave, I guess here,
and then the other is using it as an object in space you can measure strain with respect to.
So can I put maybe Chris Collins as a leader on this effort?
Yes, I think so. I mean, I guess we'll have to talk with Jan further to determine, I guess, how much overlap there is and whether it would be better to just combine them. But I will certainly start writing and then, be in contact with them.
And I would probably not sort of try to combine this, but maybe it sort of talk about the synergies between the two approaches, but submit maybe two papers. So there will be. The BPS need to feel the pressure for the community, and more ideas of exciting physics and technology. I think that's good. But think about sort of collaborating and arguing for the benefit of the technology that you have developed.
Yeah.
And so anybody else who would like to step in, and I'm putting here sort of lead, but then
I don't know what this SGWO.
Spherical gravitational wave detector, right? So I'm just spherical gravitational wave detector. So this is the talk that Chris Collins gave, right?
I don't understand that. We are talking about lunar gravitational wave detector.
Yes.
Talking about the same thing with the one.
So that should be then. I just maybe should I remove this?
Our talk was about using the whole entire moon.
Exactly. So
suggested having sort of baseline in there.
So there are two different areas. How would you like me to call your concept? Just so that's two different talks, right? So it's I guess Jan was talking about interferometric detection, and you were discussing the squids using squids.
It's two different experiment. Was proposed.
What would be a good name for the experiment that you presented?
Lunar gravitational wave antenna with the entire moon as antenna.
Okay, so let me put this way. So basic antenna. So antenna, and that I will spell out in by the end of the session, I will compose sort of the leads on the different areas, and then I will work with the document and will send for the community the summary of it. So, but for now, let me basically do this, right? So, would that be acceptable for now? Antenna. Okay, so this is antenna. So, anybody? I guess Hojan. I think maybe. I guess you will be also here, and anybody else who is in the community would like to contribute right now? Your name as a co-author on this white paper, co-author.
So, what are the differences between 1 and 2 then?
I guess Jan was given a talk about using a lunar gravitational wave antenna using, I guess, interferometric technology. which will be positioned in one side, so to speak, within the crater, right? And
Yeah.
the gravitational wave antenna using the entire moon as the detector.
Yeah, I think the concept is the same. We are just talking about different scenarios, like how you spread out the sensors and so on. I think in reality it probably will collaborate in the end. All the names that you listed there. But anyway, I think that's fine. We can sort it out later.
I'm happy with this. So I think
you could also set up an optical interferometer,
right,
going from Earth to Moon or somewhere to Moon, and look for gravitational waves that way.
and that can be discussed, I guess, in one of the Marshall alluded to using optical clocks as a gravitational wave antenna. I think Marshall will develop, maybe will lead one or two or several papers.
I mean, I'd be glad to take a lead on a paper on that. The question I would have is there much interest? By the way, I posted in the chat the links to the NIST work. That second link there is the actual general relativity thing, which was mostly on not this sort of stuff. It was mostly on like dark matter and, you know, the Bose-Einstein condensate type coherent motions in dark matter that you might see with a clock and things like that. So a little more out there, frankly.
It would be nice if we can sort of estimate the sensitivities, realistic sensitivities we can achieve from the moon, not sort of generic location, or maybe in cislunar environment, because there are some different, environmental issues that we need to address, and so it will be more relevant to the activities that we are doing, not generic use of clocks, but really within the context of lunar exploration. So, Marshall, I will look at this list that you posted, and then maybe I will reach out to you to discuss further. So, Simona, you were given a talk on the next generation of corner cube reflectors. So I think this is very important for us to continue as a community to advocate for these reflectors. Would you be so kind as to lead the white paper development on this topic?
Sure, Slava. Thanks for the opportunity and for the workshop. So as you might imagine, I will get involved immediately, Doug Curry from the University of Maryland, and any other people from his group or collaborating locally. And then for the payload we are delivering to ESA, we have a science PI from our group in Italy, so I will get him involved too, Marco Muccino. And we will expand the list. I imagine that the list will increase. Vishnu is listening now in the conference, so he is certainly a person who can get involved. So he can write my name, and then yes, we will expand that.
Excellent. And maybe using the example that NIST had done, and I've seen this also at the Lunar and Planetary Science Institute, the topics for white papers and the leads and the teams were made public. So multiple co-signers or co-authors could choose to join one or two or few papers. And essentially, we can make the same thing with this list. Once we identify the topics and iterate the titles and the scope, we can try to post the same information online so that community can look up those white papers and sign up for them to contribute to be a co-signer. So that would actually be a simpler way to broaden the effort. So we will plan to do that. So so moving on, I guess. So then I guess looking at the neutron detectors, and Jack Wilson did gave a nice talk. So, Jack, would you be considering to write a white paper? Is this can we count on you?
Yes, certainly. I or someone at APL will put together a white paper on measuring the neutron lifetime from space, and we'll also reach out to the experimental nuclear physics people who work on neutron lifetime measurements to get their input.
Have you considered applying to PRISM on that?
Sorry, I didn't hear that question.
Have you considered applying to the PRISM program on that?
So I think it's my understanding that PRISM is specifically for planetary science.
Mm-hmm.
I'm not sure if
that's actually not true. Let me
Okay.
comment on this. At least we are delivering this laser reflector payload to ESA, which is then delivering it to NASA, and that is done through a PRISM scheme at agency level. So it may be different if you do a proposal, but this is just to say that our payload has mainly a physics focus on fundamental gravity, and so this is part of the CLIPS and PRISM 1A mission to the Rhine Gamma crater 2023. So fundamental physics can be included in those missions, certainly. We are an example of it.
That's very interesting to hear, and we'll definitely look into that.
Excellent. And I see that there are some comments on the chat. I'm not able now in real time to capture those comments. Maybe I can ask Ulf or Monica to capture those comments so that we will benefit from your thoughts as you express them in real time. So thank you very much. So then, Marshall, how do you have a name for your white paper? You have written several. Well, how would you? Which one would you champion, and which one would you like to help from the community? Marshall, you there?
I'm sorry, I was on mute. Well, I mean, one question, and I'm going to have to leave, unfortunately, pretty quickly here. So, but one thing is sort of new tests of relativity, because I think you can do some new tests of relativity, general relativity, with the capabilities we're developing. And it's not just, oh, we're going to determine gamma to another digit, another decimal point or something. It's like fundamentally different things. For example, the torsion idea, that's a fundamentally different thing, right? And some of them are also like, for example, if you had VLBI beacons on the moon, and this is something I'm writing up right now, if VLBI beacons on the moon, you can do a solar bending test using the moon as a foreground object, and so the bending is different between the background object and the foreground object. And so you're kind of testing the metric in a little different way there. And I would clocks, whenever you start talking about clocks, you've got fundamental stuff going on there. I think there should be a clock paper, frankly. I think there should be a clock. What can you do with the DSAC, the Deep Space Atomic Clock? Because that's not useless either. That's a useful clock. And it's flying right now, I believe. It's flown. I know it's flown. So what can you do with DSAC? What can you do with an optical clock? Why should these things be developed and pushed? Because my experience is if you don't push these things, they just won't happen. And it's the same thing with that neutron detector. That's really cool science, and it's really fundamental and basic. And it's probably, one of the few things discussed today that might lead to a Nobel Prize if the, gods of science were favorable. And yet it's not likely to happen unless the community actually really gets behind it and pushes it. Because it's
absolutely
not like, okay, we're just going to do the next thing. It's a different thing. And
this is the time to push, exactly. So, Marshall, given the breadth of your expertise and your interest, should we subscribe you to maybe, should we ask maybe a couple papers so you can lead one, the test of GR, but also the sort of the cislunar nav that this community technology.
You mentioned that, and I'm actually working on that, and I have some other people that might be interested. And of course, Vishnu is on the call here, I believe, and there's some other people out there, and so I think. Just say cislunar PNT.
Of course. Yeah, I think that there is a lot of interest in this area, and absolutely the technology that you mentioned, and this community develops lunar laser engine, lunar radio engine, the same beam interferometry, VLBI. All of that will enable us to bring a very good, PNT signals to the lunar surface. That's good. So I think having a paper on that will be very important. And essentially how we can use all those precision sensors to study, to benefit the fundamental physics. That will be great.
So before I go, the last paper on the optical interferometer, I think that's really, really interesting, and I think some thought should be given as to what fundamental physics can be done with that, because I don't think and this is just, sort of a bureaucratic response, determining better parameters for white dwarfs or something like that, or even supernovas maybe, is not necessarily going to be fundamental physics. So what fundamental physics? Erwin Shapiro always wanted to use an interferometer on the moon to do relativity, to look for bending of light very close to the sun. That was the original idea of points, and points eventually became sort of one of the fathers of SIM, and then all that died. But his original idea was, back when we thought we'd be going to the moon in the 70s, put it all on the moon.
Gerard, with your presentation today, can we ask you to lead the development of optical interferometry white paper for the lunar base deployment?
He doesn't look to be on, Slava.
Okay, so I will reach out to him, because I think this is an important topic. And from University of Arizona in Tucson, they have a very unique group there that actually can help us to broaden that activity, and we at JPL can contribute to that, obviously. So that is another topic. Maybe moving on. So I just skip, not intentional, but basically another topic, but covered by Peter. And so that was ablation, ionization. I think that is an interesting way of using the physical technology that we develop in the community for exploration. Peter, may I ask you to actually step in and lead the white paper on that topic? And is Peter here, or?
Yes, Peter Wilson.
Okay.
So, somebody should talk to the people at Haystack about this.
Right.
Because they've done really phenomenal work. Even Alan Rogers, with the the one in Australia. What is it called? Edges, or? I mean, they've done phenomenal work there. So they would be really, I think, sort of obvious people to get involved.
And maybe we need to work with the leads once we sort of not identify, but we sort of put them on the list. Maybe we need to work with the leads and try to broaden their thinking as to what the response might be, what the white paper. So, but maybe Marshall, you and I, we need to chat.
That's really fundamental physics too, because you're looking at like the early cosmic dawn, right? And even now we don't understand really Alan Rogers and company's results from Australia. And so that means we might not understand early cosmology. And so, I mean, maybe it's just systematic error or something, but it might be something more profound. So, all this should be brought out here, I think.
Absolutely. And so, so that's relevance to cosmology and sort of a broad reference to astrophysical research would be nice. So maybe slightly moving on the CLRT. So that is an excellent topic that was discussed by Ashish. And so that is something I do expect that he and his team will contribute quite strongly to this topic. And so, Ashish, are you here on the call? I guess
I would be definitely happy to help write the white paper on this topic. In fact, just as looking for feedback, there are two ways I'm thinking. So as was mentioned in the chat, there are a few different telescope concepts for doing early universe cosmology or early universe science in general, by using moon as the surface of the moon as a site for developing these telescopes. So I can think of two ways of doing this. One is a very specific paper on the LCRT concept and what it needs, what technologies would be needed for it, sort of a thing. And the other is general early universe cosmology from the moon. And you can then bring in all these different ideas that are out there. So we can reach out to a bigger community of people who are interested in this.
And Ashish, I think you may also discuss maybe the lower frequency, low frequency gravity sensors on the near side.